Thank you. So, hi, I'm Benjamin. I work as an Android software craftsman at Navoda. So Navoda is an Android-only agency. We are based in Berlin, London, Liverpool, and now even Barcelona. And the reason I'm talking to you today is because at Navoda, we pride ourselves in creating clean code, tested code. And I'm myself a strong advocate of learning from functional languages, functional paradigms, to enable ourselves to write cleaner, easier to test code. So let's talk about what is functional programming. As the name suggests, it's about using function as first-class citizen. That means being able to use functions the way you are using your usual data variables. You can keep a hold on them, pass them around, and compose functionality. This means having high-order functions. A high-order function means that you have a function that can take another function, or even return a function as a result. We can use that to create, compose, and have a high-level language, a high-level way of expressing ourselves to create the goal we're trying to achieve. This means having the ability to declare lambdas. So a lambda is an anonymous function. And the idea is really to be able to lift away the pain of having to declare a class to create a method, or having to declare a utility function. If we need something right now, we can declare it as a lambda and pass it around. Another core concept in functional languages is immutability. And I will dive a bit more later into those concepts. But the main key that I want to get to you is it can be enforced by languages. We have languages helping ourselves to enforce those paradigms, but it doesn't need to be. You can do that yourself. Same thing, we talk about pure function. Those are like concepts which every single time people talk about functional languages, it's all about, oh, this language is pure, or this language is whatever. And it can be enforced by language, but it doesn't need to be. So let's back up a bit. Why are we even talking about this? Why should you try and understand what is a functional approach to solving a problem? So the main idea is we want to write smaller code. We want to write code that we can glance over and understand. We want to write more expressive code. We want to remove all the boilerplate, all that useless code that is only there to help us achieve our goal, not expressing what we want to do. And we want to write small units. We want to write pieces of code that we can reuse, we can fully test, and have control over. But the main idea is we want to focus on what, not on how. Who here in the room is like a musician or knows how to read music, write music? Good. So you're probably using this. That is the way you interact with music, a music sheet. It's a language of notes and symbols that allow us to express what the music is supposed to sound like. Is it small? Is it forte? What tonality is it? And this is a high-level language that allows us to express ourselves. You're not using this. You're not representing how the sound is moving the air to get to your ears, because there's no way you can actually create something beautiful using this, let alone understand what's happening. And that's what we want to achieve with code. Why do we have to focus on iterating through a list to do things, like having a hash map of items? We want a high-level language, higher than what we have right now, to understand concepts, paradigms, what we try to achieve with our data. And this is what functional languages and functional paradigms allow you to do. So what are those core concepts? So as I mentioned, the first one is immutability. And as the name suggests, it means nothing can change. Wait a minute, we do need to make things change, right? So the idea is, if we have a value and we want to modify it, instead of mutating it, we're going to create a new value that represents the modified version. So why do we want to do that? Why do we want to use this weird concept, which doesn't sound really natural? It's actually to solve a way more bigger problem that seems even less natural. So imagine that I have an apple in my hand. I take a bite, and I give it to you. Once you have it in your hand, I have no way to modify that apple. I'm not going to take another bite in it and change it for you. You have it, you hold it. But this is in the real world. We're talking about program. If I give to you a value, I can keep a reference to it. And if I could take another bite in it, all of a sudden you're holding something that changes. This is completely non-natural. This is something we don't expect. And those things, we can't reason with it. It's too far out of our way of conceiving things for us to be able to properly understand them. So we want to avoid that. And to avoid that, if I take a copy of that apple and give it to you, it's a different one. And if the way that apple is designed prevents me from modifying it, then you're safe. You're safe to cache values. You're safe to keep a hold on something as long as you want. And you know that the only reason it's going to change is because you decide. And pure function. So a pure function, the idea is it's a function that will always give the same result if I always give it the same input. And once again, it's about predictability. It's about understanding easily what's happening. I can take an example. In Android, who here has worked with the account manager? Remember this nice getAccount method? And you call getAccount, and if the account is not there on the device, it will fire up an activity, prompting the user to log in, create an account, and then return the account to you. But if the account is there on the device, it will just return the account. As a developer, when I call that method, I have no way of knowing what's going to happen. It's not predictable. And this is confusing. And you can solve that problem by saying, I'm going to split that into several functions. I'm going to have, is the account present? I'm going to have create an account. And I'm going to have get an account. And now, I have a predictable way of using those methods, and they're always going to return the same thing. So breaking it down into smaller components, and one of the key principles, if something is represented using multiple values or using functions that might return different things during different circumstances, usually it's because you haven't broken down the problem enough. You're not at the correct level. So what I mentioned is no side effect. So when someone said no side effect, that's what they mean. They mean we want that function to be predictable. We want it to not do anything else apart from what it's saying. Get user should return to me a user. It shouldn't do anything else. And this is to achieve what we call referential transparency. And what this means is if I have get user, I can replace it by the user and not change the behavior of my program. If I get user and it's creating the user, if it's not there, if I just replace it by the user, the account is not created. And this creates problems. I have no way of understanding what's happening behind the scenes. All in all, what we want is reducing the number of moving parts. We want to avoid asking that question. What is this doing? We want things that are simple enough to understand them. We want to have predictable code that we can reason with. OK, you're going to tell me, oh my god, this is a nice idea, but it's really crazy. What language can I use to do that? I'm going to have to use Haskell, all those weird languages that nobody wants to see. Well, it's not true. You can use any language, really. Some languages are going to be easier to implement those concepts in, less boilerplate to do them. But you can use Java, C++, Python, and of course, you can use more functional languages such as Kotlin, Scala, and so on and so forth. But the key idea is it's not about the language. It's not about the framework. It's about the ideas and the way you approach a problem. So I know we're all Android developers here, or at least a lot of us. So let's talk about Java 7 and lower, because that's kind of what we're stuck with. So you can use toolkits, frameworks, libraries, such as RxJava or functional Java, to help you bring lambdas, some collections, transformation, and things that come from the functional world into the Java world. And this is really nice. We can use those libraries, those frameworks, to help us avoid boilerplate to apply those principles. We can use auto-value. If you want to write immutable values or collections in an easier way, auto-value is a really nice library. It uses annotation processing to generate classes with equals, hash code, and all those boilerplate functions that you have to re-implement every single time you create a value object. And most importantly, it will enforce that things can't be null. It will enforce that you can't mutate things. And it just helps you bring that to Java. But you don't have to. I mean, what about Kotlin? Who here was in a Kotlin talk yesterday? Most of us. So Kotlin is a really nice language. And one of the things I enjoy the most out of it is it's fully compatible with Java. As it was presented yesterday, you can use Kotlin files in Java or Java files in Kotlin. So that means if you really need to do something in a functional way, and you don't want to do that everywhere in your app because you're not really certain yet. So just take one part of your app. You say, that thing is quite complex. I want to migrate it to a functional way. And you do it in Kotlin. And then you don't need to change the rest of your code. It's a really nice way to slowly get into it. And it's a really nice language to explore. So I'm going to use Kotlin in the rest of my talk for snippets of code. And if you've seen the talk yesterday, you would see that it's quite similar to Java. If you haven't been, the first line is a function that takes a string as a parameter and returns a string. The second here is a higher order function that takes a parameter, a function as a parameter that takes an int and return an int, and overall that things return an int. And the last one is how you would define a lambda. And this one takes two ints and sum them. So the syntax is not too far off from Java. It's actually quite easy to get used to. And when I'm presenting some snippets of code later, I'm going to present them in Kotlin. But keep in mind, those things can be expressed in any language. It's really about the way you're going to approach the problem more than using a toolkit or using something. So let's get functional. So this is a quite complex way of representing counting words. If I want to have a collection of words, and I need to count how many occurrences of each word is in the list, most of the time, in an imperative way, you would have to do something like that. You're probably going to extract the if statement or some things to try and clean it up, but there's going to be a fair amount of lines of code. In here, I'm setting a hash map and iterating through the items and having some check. But all of that, it focuses on the how. It doesn't focus on the why. Glancing at this, I don't realize initially that it's actually counting words. Whereas I can refactor this. I can refactor this in a more functional way. And it might not look as easy to understand if you don't know the concepts, but you can agree with me, this is more concise. This is more concise. And if you look at it, even without understanding the concepts, you can see that this is words.group by word. It's already sort of telling you what it's doing. And the most important thing, you don't have that iteration over items. You don't have the concept of hash map or whatever. The only thing you say is, I'm grouping things by words, and I'm returning them as a pair of key and count. And yes, it's a bit of a learning curve. You need to learn those keywords, grouping, mapping, and that. But once you have them, once you understand them, then you can express things in a much more concise way, and you can express them as the what, not the how. This is expressing that I want to group items by word. The other one was expressing that I wanted to store them by key value. So we want to write self-explanatory code. Anyone who has read like clean code or any other like kind of language guide, we always talk about this. Let's write self-explanatory code. But that doesn't mean the method name should explain what it's doing. As in, yes, the method name should explain what it's doing. I was calling it foo right there, which is pretty silly. But it's to showcase the point. If you use the method name to explain what the method is doing, it's as bad as just writing a big comment on top of it and say, I'm done, I explained it. 2 months down the line, the code can have changed, and the method name hasn't changed. The method name doesn't represent what the code is doing anymore, and that leads to bugs. We want that method name to be the contract with the rest of your code. the way you understand what this is doing without going into seeing what that method is doing. If I call that method, I want to know what it's doing by reading it. If I look at that method, I need to be able to see what it's doing just by glancing at it. I need to understand straight away what this method that says it's counting the occurrences of words, is it actually doing that? I need to be able to check it quickly. If we understand our code in this glanceable way and summarized way, then we won. So we want to keep things small and concise. OK, so it's also allowing for extensibility. So now if I take the same example, counting occurrences of words, and now I want to count only the items that occurred at least 3 times. I want to sort them by occurrences, and I only want to return the word, not the count. I can show it like this. I will use functional concepts to compose over my list and say, I have my count occurrences, so that's the method from previously, and I will filter on top of it. I will sort on top of it, and I will map on top of it. And those things are quite concise. The thing that actually represents what we're doing is this line, and it's quite expressive. I'm checking against a threshold. I am sorting it by the second element in my pair. And we can even get more expressive by extracting them into more meaningful names and so on and so forth. But the key idea is we don't have all the boilerplate of what you would have to do with a for loop with an if statement inside and so on and so forth. So you're going to tell me, yeah, that's nice. What about real cases? What about what I'm going to do tomorrow? Well, all of the things I just showed were real cases. And if you don't trust me, the only way you're going to go from seeing something that you need to achieve to the way to achieve it functionally is focusing on the data. Focus on what you're manipulating. You're probably manipulating article, product, users, values. Those values can be made immutable. They're the things, the concrete objects you're manipulating in your application, in your model. And then you're probably handling lists of those. So I have a list of users, a list of products. And upon those collection of values, I'm going to do transformation, processing. That's what we're doing. We're taking input and giving an output. So we're fetching a list of users. We are calculating the price of a basket. Those are things that you're going to do every day. And this is taking an input of those values, like list of values, and returning an output of those. It's as simple as that. If you consider the core of your application, the model bit, this is what you're doing. Of course, in the UI, you're going to be a bit more, I want to display something in a text view. I want to display things in a list view. But ultimately, when you fetch data from the network, when you order it, sort it, process it, all that complex logic can be expressed in a really functional way. So think about it like shell. When you do a shell computation or something, you're not going to do this. You're not going to do a script in a file and just run it every single time. You're most likely going to do something like this. You're going to use the tiny bits of command shell and pipe them together, because you have those small reusable components that are the shell commands, and you combine them together. And that way, if tomorrow I need to sort them differently, I don't need to go into my file, change that file. I just take this, change that value here, and all of a sudden it does what I want. It's exactly the same thing. What we want to do is create a language of small functions, small domain functions that you can reuse in your application to deal with your data. So in functional languages, we have a lot of really, really powerful tools above lists. We have the ability to map, flat map, filter things, merge, combine. All those things exist predefined for you, just waiting for you to use them and combine them together. And the idea is really try to slowly get to know them and use them. You can extract things from lists using first, last, and so on. Or you can use some more advanced concept like fold that I will get into a bit later. The main idea is I want to see what I'm trying to achieve and decompose it. The way you would decompose your thinking in shell, it's the same thing. You try and decompose it into smaller components that can be expressed using those functions. If I want to only use some elements from a list, it's going to be a filter. If I want to transform the elements in a list, it's going to be a map, and so on and so forth. So let's take some examples. If I want to display the saved articles in a list, if I want to only fetch the items in a basket that requires an age check, it's a filtering of a list. All of that can be expressed using a list of items and a filter. If I want to get the total of a basket, if I want to find an item in a list, anything that requires traversing a collection and producing a single output can be expressed using a fold. So what is fold? Is this some kind of dark magic? No, it's not. It's a simple concept that can be extended to the extreme. Fold is applying a function to every single item in your list and using the output of the previous iteration in the next one. Let's be a bit more concrete. So fx, if every single time I call it, x is going to be the element in my list, and y is the result of the previous pass. So let's apply it to something simple. I want to find the maximum in the list. In here, I want to find the cutest squirrel. So I will take my first element in my list, and I need the accumulator. So I will take a default value. I will take a really not cute squirrel, a really ugly one. And I apply my function, and I get the cutest out of the two. What I'm going to do now is it's called again. It was going to be called with the second item in my list, and the result of the previous iteration. Once again, we apply that function, we get the result. And so on and so forth until we have our winner. We found the cutest squirrel in the list. And all of that was done for you. The traversal of the list, the reuse of the previous iteration result and all that. The only thing you need to do is say, oh, if you give me two squirrels, I can tell you which one is the cutest. Which is what you want to express. That's actually what matters to you. Not the traversal of a list, not the computation of a result. So let's take a really concrete with code example. I want to calculate the total of a basket. So you have a shopping app. You have a basket with a collection of items. And you're in your UI, and you need to display something at the end. That's the total. What do? Do you have it stored somewhere? And then every single time you need to recompute it? You can do. You also can compute it on the fly. No matter which way you choose, you're going to have to compute it at one point. So the way you would do it normally is to say, I have a collection of items, which is my basket, and I have an item, which is a string and a price. I'm interested in a price here. And you could do it like this. You could say, I'm going to initialize my total at 0. I'm going to do a for loop for all the items in my basket, and for each item, I take the total, I sum it to the next price, I update the total value, and at the end, I return the total. But this is a lot of boilerplate, because the only thing that actually matters is this, right? That's what you're doing. You're doing a sum over everything. So we can represent it like this, using a fold. And yes, fold is not something you're familiar with, but if you look at it, the only thing that is expressed here is I have my initial value, and I have how I process each item. For each item, the next iteration is going to be the total plus the item. It's the exact same thing. It's the exact same processing, but in here, I only focus on what I want to achieve, not how I want to achieve it. So right now, you might be saying, oh my god, this is awesome, I need to try that right now. But most likely you're going to be, I'm super confused, this is a lot to take. And it's fine. It's perfectly normal. This is a lot of things, it's a huge world, and you don't need to do everything at once. Don't do everything at once, it's way too much. So let's keep things simple. So let's start small. Today, tomorrow, when you start working again, you can start by making things immutable. Take the values that you process all the time. Take the things that matter the most in your model and make those immutable. It's a simple change, and it will make wonders for the predictability and understanding of your code. Secondly, aim for pure functions. Obviously, everything is not going to be pure function. But if you're doing something that is dealing with your models that you just made immutable, let's try and avoid side effects. If you can push back maybe logging slightly outside a stack function, or in the example of the user, if I can create my user outside of the way of getting it, it's already a big win. So if you have to create something that is non-predictable, ask yourself, do I need to do this here? or can I push it outside? And mainly, keep in mind, focus on what you want to achieve, not how you want to achieve it. And if you keep that in mind, it will help you break things down and understand more clearly how you should represent things. Keep learning. You start small, and then you just keep learning new things, keep experimenting. Learn a functional language. It doesn't need to be something you're going to be using in your day-to-day job. It's probably not going to be something you're going to use in your day-to-day job. For me, this was Haskell. And I really think it's a brilliant language to help you understand concepts because it's actually forcing you to use them. And it's going to challenge you to think differently, solve problems differently. And by having that mental challenge while you do it, it's going to make it easier for you to break things down in your day-to-day job. You're going to see a problem and be, oh yeah, this is actually 3 smaller problems, and I can break it down like this. So learn a functional language. But do it on a pet project, doing on something you like, something you enjoy. The main thing you want to do is have fun. You want to enjoy what you're doing because that's the best way to learn. If you find something you enjoy doing and you apply some functional principles, you're going to remember those because that was the thing you did on that really fun project, not something you had to do in that really dreadful thing that lasted for 3 months and you were really, really tired of it and you wanted to do something else. So keep those principles in mind, try it, and you'll get more comfortable. At one point, you'll just be owning it and bring it to people around you. So dive in, get some reads, read some books around it. It's really brilliant. I have a few recommendations. Learn Your Haskell for Great Good. It's a brilliant book to start learning functional programming. It takes things like from the beginning, really simple, and build it up slowly. You can take all the time you want. Just take the book, take a computer, and start playing around with it. That book is actually free online. There's a downloadable EPUB and PDF as well. And you can obviously buy it to support the author. But what I mean is, it's not a big gap. You can try it tonight if you want to. Just like take the book, read it, and start doing the first pages. It's simple. Functional programming in Java. This is a book that was written around Java 8. But as I mentioned, it's not about the language. It's about those principles. And you can learn from those principles in Java 8 and bring that to other versions. Or who knows, maybe when we'll have Java 8 in Android, right? And last but not least, category theory for programmers. This is actually a book that is being written right now. It's a collection of blog posts that are available online. And it's a bit on the more advanced side of things, so it's probably the last one you want to check out. But it's really interesting in a way where the author is presenting some functional concepts that come from the Haskell language and then showing you in C++ how you could do it. And really drawing the parallel between math, Haskell, and C++, and showing you that it's not about the language, it's all about the concept and the way you approach things. So here it is. Do you have any questions?
Thank you, Benjamin.